Welcome to the High Flyers Club. This is a study of aerodynamics and the forces of flight. Ever wondered how a 150,000-pound jetliner gets off the ground, much less how it stays in the air? Oh, there's a whole bunch of science involved in the forces that keep it up there, and a whole bunch of engineering that goes into making that happen. We're going to be looking at how a plane works and what are the design elements that help it to work better, as well as what are the forces that act upon a plane that the designers and engineers have to take into account. First, you're going to go to my eBoard. When you open my eBoard, you're going to go to the second grade tab, which is here. And you're going to go to the High Flyers Club. And then you're going to scroll down about halfway down the eBoard. You're going to see Virtual Airplane Simulation. You're going to click on that link, and that's going to take you to a Smithsonian site for a flight simulation. When you open up the screen, this is the intro that you're going to see. You'll see we have our trusty test pilot here, who is brave enough to venture with our designs, even though we don't know the slightest thing yet about flying, so he's very brave. But pay attention to the intro. There's some really valuable information that is given to you in the intro that will help you make really informed decisions about your plane design. Also keep in mind that you are going to be keeping track of the trials that you make. Meaning when you change the design engineering elements of your plane, you are going to record those on the chart that I will give you. This is your data collection sheet. You'll have options you'll be doing actually 2 different simulations. One to see if you can get a plane to fly at the highest altitude or height. And the second simulation you'll be doing is flying a plane the fastest. So we're going to start, as you can see with this one, we're going to start with the height or altitude. As you do your trial, you'll make your number here and you will record the material you're using, the style of wings, the fuselage or the body that you've selected, the thrust, or the engine, and then after the test is completed, you'll record what the altitude was that was reached by that design. Once the introduction has completed, this is the first page that will come up, and it'll say try it for yourself. You'll notice that there are 2 button options. One is to create a plane that flies higher, and the other button option is to design a plane that flies faster. You'll also notice that it talks about some of the forces that you're going to have to work around as you choose your designs, things that you're going to have to take into consideration. The lift that gets the plane off the ground, the thrust that moves the plane forward, the weight of the plane, and that gravity works on the weight of the plane to keep it down, so you have to adjust the other elements in order to get that to be corrected in order to get lift. And then there's drag. Drag is the air resistance, the size of the body, the size of the wings. All of those things contribute to the drag that is created by your design. So for this experiment, or this simulation, we are going to start with create a plane that flies higher. So once you click on that button, this screen will appear. And you'll notice on this screen that it will briefly go through lift, drag, thrust, and weight, and give you a little bit of information about that in this box. Once it's gone through that configuration, you'll click the Get Started button that's here. And the Get Started button will provide a different page. And oops, sorry, I've got to get rid of that. And this page, in this case, the first thing we're looking at is what's going to provide lift. Now, if you notice, there's a darker green highlight around this first set of wings. That is because this wing is the same as this wing. It's the one that's on the default plane that we started with. But there are three other plane wings to try to find out whether or not they would fly more efficiently. Now, the important thing is that you really pay attention to each of the screens and the information that's given on the screen. It's really easy and really fun just to click and click and click and change the designs, but unless you're collecting your data to make sure that you've noted which designs you're trying and how successful they were, and also that you're reading the screen, you're really not effectively making informed decisions as an engineer would do. An engineer, they do a lot of trial and error, but they also really keep track of what they do, and they make informed trials, and so that they hopefully limit the number of errors they make. So you'll notice here it tells you that we're trying to reach a height of 37,000 feet. This initial flight was, you can see the arrows pointing here, 7,000 feet. So we did not reach our goal of 37,000 with this particular design. But we have options to change the designs and see if that becomes more effective. So our plan is then to choose a design, and let's say we choose the DC-3, and we click for it to do the test, and it comes back and it gives us information, and you'll notice there's some information written here in the green box. That a big wing, it lets you know that a big wing creates lift and increases your altitude. But then look at number 2. Eventually, the thinner air reduces the lift of the wing. So you'll get up so far, but not as far as you want. So be sure to read all of these in order to give you the most informed knowledge about which design elements and components are going to really give you the best flight. Also notice that our altimeter, which is here, gives you our altitude. The altimeter says that this particular configuration went 13,000. Now that was better than the 7, but we're still a far cry from our 37,000. As you can see, we have lift, and that gives you the choices of many different styles of wings. That provides the lift for a plane. Drag, which is the air resistance, different body types, or what's called a fuselage, will in fact change the amount of air resistance or drag. We have thrust, meaning that we have different engine types that we can try. A piston engine, a jet engine, a rocket engine. And finally we have weight. The weight of the plane is determined by what it's made of. So we have wood, aluminum, or a combination of things, which is composite. As you trade off some of the different design elements, you'll see by looking at the altimeter whether or not that was an effective change, or did you get better results from something else. Always refer to your data chart and make sure you keep your data chart up to date as you're testing in your team. Otherwise, it'll be very hard for you to make the informed decisions you need to make as an engineer would. For example, this is a jet engine, and I ran a test on this, and I took a screenshot of the test. a little bit after the test had kind of happened. And you can see there's a little bit of a problem. Our test pilot is not particularly happy. The jet engine didn't seem to work very well. It looks like the jet engine made it to about 7,000 feet before it didn't seem to want to go any higher. Certainly a far cry from our 37,000. But if we look at what was going on, and we read the test results, this will really help us figure out, wow, what was that? And you can see a jet engine provides more thrust. That increases the speed. Great, well, we're trying to go higher, not necessarily faster in this particular simulation. And we can read the rest of this to get more information about whether that was a wise choice. But I think our biggest telling point is here. It says, your wing and fuselage cannot withstand such speeds and broke apart. So that's why our unhappy test pilot is feet in the air, in the ground. He's probably not going to want to test any more of our planes unless we do a little bit better job. But you can try again and start over in order to redo your designs and try some different design elements. Again, always remember that you need to collect your data so that you can so that you're informed in making your decisions, not just haphazard, but really being a little bit more intentional in your choices. Once you have completed and really have reached your 37,000 feet, you can move on to design a plane that flies faster. We know that the jet engine, although it didn't succeed with the fuselage and the wings that we had on it, we know that that flies faster. What can we learn about our designs that we did for height that might help us make better decisions on our designs for speed? So you will fill out another data sheet for the speed, but look back at your data sheet for the height and the altitude, because there's some information when you saw something that broke up or what happened to it. That information can be useful in helping you put together the most effective design for speed. And finally, you're going to be doing this. You can do this as enrichment in your classroom when you finished your work with your teacher's permission. You can do it at home if you have access at home. What I expect of you is that you will have run this trial and finished your data collection sheets, and you'll come in to class ready to share what you found as your successes and what was not so successful, and what you learned about the forces of flight. And we'll share it together and see, does everyone agree, or are there different combinations that really worked effectively to give us a plane that flew the highest or one that flew the fastest. So I'm looking forward to hearing how your simulations turned out, and we'll see you back in the classroom.